Hello, I'm Amar. Through this short video presentation, I will discuss about my past activities, skills, achievements, and my future direction and motivation. I am an Erasmus scholar with Masters in Mechatronics. I aim to improve the deficiencies of society through technology. I did my bachelor's in mechanical engineering, and my research interest, starting from mechatronic systems and structures, converges to robotics and artificial intelligence. I have also worked with different STEM-based education startups and robotic companies during this tenure. Now I will discuss how my interest moved towards mechatronic systems, which developed my interest in control, automation, and artificial intelligence. Within the mechatronic domain, I did several projects related to computer-aided design and manufacturing, such as these smart bin concepts designing for a government project and a small CNC setup at a company and their technological advancement towards PCB designing through it. One of my most influential projects was initiating to build a fuel-efficient real-world car in our garage, and later through gathering the investors and sponsors, uplifting it to Toyota Motors, while being the design and technical head of the team that had a huge impact on my personal and professional growth. Later on, we successfully completed the technical inspection test in Singapore. The pivot point where my interest deepened towards robotics was when I designed, built, and programmed a wall-following robot that won a competition at a regional level across the city. Later on, being the design head of the robotics team at national level, we won the Best Engineering Design Award. While returning back from the competition, we discussed about how to optimize the design more so that the dead reckoning error can be eradicated. This idea kept me thinking until I came up with a solution to make all the four wheels rotate by the same motor to have same speed, and add another motor with bevel configuration just for the turning purpose, which got published internationally, and one year later, based on a journal publication, we developed the first successful prototype based on that exact design. Exploring the field of robotics, I got interested in its aerial applications, where I built a tricopter extension for a company to be added to the robotic kit, and a quadcopter as my personal interest that led me to help others in such projects. We compete in several competitions, and later, when I was interested towards the autonomous configurations, I successfully tested its waypoint-based autonomous flight in the university ground. My inspiration towards the age of modern engineering and empathy for physical impairment created pathways to move towards merging the concept of accessibility into future technologies. At a research company, we developed several assistive technologies such as a cane equipped with sonar sensors and a GPS-based glove that served as the guidance for the blind through haptic feedback. For this reason, I deemed mechanical engineering had provided me with the foundation. Further, a little edge of mechatronics and artificial intelligence is something that is needed to shift towards achieving my aspiration. Therefore, I applied for Masters in Mechatronics Engineering through Erasmus Mundell Scholarship and achieved first position during the first year and into the top 3% later on due to my immense passion in the field. During my master's, I focused my interest towards automation and integrating artificial intelligence to it. I developed a feature-based multi-object tracker based on deep sort and Siamese triplet training model processed through Kalman filter for autonomous boards, and I also controlled its command through decoding the controller area network messages for my master thesis. One of the need in robotics is high-level robust control and sensor-based awareness to reduce failure rates. One of such projects of mine was to stabilize a flexible beam through PID and robust controllers. The picture depicts the schematics Simulink block diagram for its control and reference tracking and step response for a real-time hardware-in-loop simulation. As a research assistant at National Center of Artificial Intelligence, I focused my works towards stereo vision setup and led team to fabricate and control an autonomous weed removal robot. I also programmed autonomous navigation through Carla Ross Bridge on Docker and developed high-definition LiDAR and RGBD-based maps of the environment, which later led towards localization and autonomous path planning and navigation by sending control command via robot operating system bridge. Real-world implementation of such methodology and using simple computer vision lane algorithm, I also developed an autonomous lane-following car. And finally, I would like to add that my inspiration is to offer the world a generation without suffering from disabilities, or in other words, by automating the environment or world around them. I'm highly motivated for this position as it aligns with my passion towards autonomous systems and for their optimal and robust control leading towards multi-robotic systems and agents. Here is the picture of my beloved grandmother having high hopes to see this illustrated future. Thank you.